those are our next couple meetings, so they are already scheduled, so you can see when those are and get started on that. Today, I'm really excited to have Andrew, one of our organizers, speak about documentation, recent developments, and how to organize and write documentation. So I've been looking forward to this talk. Some things that maybe I can use myself. So I'm excited to hear it. So thanks so much for preparing this.
Not exactly on documentation, but it's more on along the periphery of what's come. I've got some cool stuff that has come out of my work in documentation, and hopefully my green screen doesn't fall over on me. So that's the green screen for YouTube, so that I don't entirely block the slides when I'm presenting. So maybe go afterwards, and it's going to come down. I know it's going to come down. It's for YouTube. Yay! Thank you everyone for subscribing to YouTube. We finally got enough people to. Yeah, we finally got enough people that we can have our own custom URL. So it's youtube.com/c/slc rug. So I'm sure the people that are watching on YouTube already know that, but thank you everyone for that. So yes, documentation task force. It would help if I were actually on my presentation. So what is the R Documentation Task Force? It was a project that was proposed back in July 2016 and then funded in October that fall. So I heard about the R Consortium call for proposals, and I'm like, hey, documentation, it sucks. We can do better. So I said, I'm going to throw in a proposal, and we're going to do something better on documentation. So what can we do better? The first aim is to abstract documentation in a way that encapsulates everything that we see in documentation, the arguments, the notes, the warnings, the output, all that needs to be abstracted can be abstracted into an object or a class system. And then make recommendations about how documentation can be formatted. Who here has actually done a package before? Okay, I've got 3 of you. Who here has written any documentation for anything before? Anything? Anything? Yeah, okay. Okay, documentation kind of sucks. It's not the funnest of activities that we could be doing. The right tools make it a lot simpler. I come from a background of computer science and programming, and I've been a C++ programmer for a long time, and I know deoxygen, which is the R oxygen for C++ and C that predated R oxygen by a long time. So that makes things a lot easier. But there's some features that are missing in R oxygen that I really liked. And so I was working on how do I get some of these features implemented across. So the last aim is implement everything. So we make an abstract class system, recommendation of how we should store documentation. So some history is, and there it goes. Okay, well, I'm sorry, I tried. We'll keep I'll get better tape next time. Next time I will duct tape it to the wall, but sorry about that. It will mask a little bit of the slides on YouTube. That's why that's why you should always come in person if you can. It's always better in person. So, history of documentation. So, when R was originally conceived, the documentation for everything came in RD format, which is a variant of LaTeX. So if you haven't played with LaTeX, I don't recommend ever going out and just trying to do it. There are more sadistic things that you could do, but not many. So then along came R oxygen, or Roxygen as many people call it. I call it R oxygen because I always called it D-oxygen for C++, and it's always been R oxygen, not roxygen, which was great. It was a massive leap forward of putting documentation where it belonged next to the code that it's documenting. It's great, but it's still a patch on top of the system of RD. So basically, roxygen changes documentation from the source files into this RD format that then's processed and put into a package. What does this all mean for the RDTF? Is that we have to have a paradigm shift from what was to what is new. So the old paradigm, as I explained, it was all separate files, plain text. All the files were independent, so your code very often got updated, and your documentation didn't. Yeah. Then all the documentation is static. It doesn't change at all if anything in the code changes. And it's also location dumb. And this is the problem that I have with Roxygen, is that it is still moves code a lot closer, but it's still location dumb. It doesn't say, if I'm putting a comment next to this thing like an argument for a function, if I put a comment there, that it should be documenting that argument. It's documenting whatever it's closest. And it depends on the package system. I can't count how many times I've just received R code and said, here's something to do, and it's like, okay, what does this do? If there aren't comments in the code, it doesn't mean anything to me. And to build a help file and build everything, it requires building things through the package system, which is great, and there are lots of great tools, and it's wonderful, and I'm not dissing on the packaging system or anything, but we can do better. So what's our new paradigm? Everything in documentation, all the documentation is an object. So similar to how R can create functions, R can operate on the language itself. I wanted to carry that over into R can operate on the documentation itself and say, create documentation dynamically, create it dependent on other things, link documentation things together. So it's an object, it's programmable. And the documentation objects are interdependent, not independent from the code. And they're dynamic. You can change, they can change in real time depending on how things in your code work. And there are lots of ways that you can represent it. RD is one format that is not very great for lots of people. With this system, all you have to do is create another module that will say, pull in documentation from an HTML file. Maybe you've got HTML files where people can go in and add examples. And when you load it up, you can say, OK, fetch me the latest examples from rdocumentation.org. And it'll pull out all those examples to your local machine. And then you can package them into your code or into your package if you want. All of those things. Location aware. It documents what it's close by. And it's instantly available. You don't have to wait for something to be packaged to create a documentation. This is an example of the code that I'm talking about. So this is an example from Parse Tools, which is one of the packages in the R documentation ecosystem. And this is a function that creates another function. I have a need for a lot of these convenience helper functions to make my code readable, which is wonderful. And if you have all of instead of copying and pasting code, I just have one code that I can test it really well, and then say, OK, just have this function create me a function that does what I want it to do. And then I get a whole bunch of other functions that are derived. Now, none of these have RD tags with them or comments. but each of these could have documentation generated and says, is set class call? I could have that a documentation object that says, this is a function that checks parse data to check if the node is a call that corresponds to a set class. That probably didn't mean anything to you guys, but it means a lot to me. So this is the documentation ecosystem. These I consider the core packages. The documentation package itself, the one with the gear, RD, which is creating and manipulating RD files, and Parse Tools, which handles parsing data. These I consider auxiliary packages, and that's where I'll spend most of my time today because I think it's the most interesting for everyone. And these have general applicability to anyone who is developing packages, developing functions, just writing R code. These are the ones that you want to pay attention to. And then I've got some experimental ones that I'm not sure the right road to go down, but they are becoming more and more interdependent with the others as development goes on. Okay. PKG cond, package conditions. So, package conditions, errors, warnings, messages. The baked-in error system sucks. Who's gotten an error that they have no idea what it means, no idea where it came from, no idea why my code is failing? If you don't have your hand up, you're lying. So, yeah. So let's try helps. It works for simple problems. Patch does better. There's a lot of things that go around it. When I'm writing something, I only want to worry about my stuff. I know everybody else is a bad programmer. I don't want to have to worry about their errors. I'm a fantastic programmer, so I just want to fix my problems, right? No, I know there are fantastic programmers out there, and part of that is that good code produces good errors. Errors happen. They are a part of coding life. We have to plan for it. Let's take a second and talk about terminology, because R uses somewhat different terminology than the rest of the programming universe. So an error is errors, warnings, and messages are all conditions in R. And they all signal something to the user or other parts of the system. In other languages, especially errors have different terminology. They are called exceptions in C++, or they can be called, and I'm drawing a blank on what the other term I was gonna say was. But we also talk about throwing conditions or throwing exceptions, which means I'm going to take this condition and throw it up the call stack and say, somebody want to handle this? I don't know what to do. Or here's a warning. I'm going to go on ahead, but if you want to stop me, go ahead, kind of thing. So, what makes a good condition? Good code produces good conditions. What makes a good condition? First off, it needs to be informative. It must carry information about the conditions being raised. Was it an input error? Was it a failure to converge? Was it an act of God? What happened? Can anything be done? So like an error is different than a warning. Warning says, something's wrong, but I'm gonna push ahead. Whereas an error says, I can't go on at all. They're both conditions, just differences of severity. And useful. Anyone here do SQL in R? Anyone ever gotten this is a bad SQL statement, and it shows you the SQL code, but you never get to the error. Yeah, it's annoying. So that's not a good error code. Sorry to point fingers at that code, but a bad SQL statement is not a good error message. An SQL statement, an SQL error that says, there's an SQL syntax error and this is where it is. That's a useful error message. And errors need to be part of the interface. So for example, in Parse Tools, the public-facing functions all check their parameters. And if it does not pass muster, then it gives a bad document error. And you can count on those functions. If there's an error in the arguments, that's the error, the type of error that will be raised. So package condition fixes this by giving errors with the proper information, such as where did it originate, and it can carry along information, other information that needs to be carried on. Now, to be clear, R already does this, and package condition is basically just making it a whole lot easier to do these things. But there needs to be easy ways to do it, or people won't do it. So it's very simple in your programming. You take all your old calls, stop, warning, message, and assert that, and you translate those to new calls. Package error, package warning, package message, and assert that. Yes, it just masks over the assert that, but when you call it from package condition, it will add on a whole lot of more information and let you know that it's an assertion failure, not just a generic error. So specifically, what do these functions do? Sorry, voice. Throat getting dry. Okay, so you call package error or package warning, and it says, okay, first, where was I called from? Was I called from a package? Was I called from a method of a class? Was I called from a function belonging to a package? Where does this error belong? And then it adds all that information onto the classes to categorize the errors. And yes, it uses the S3 class of systems, the S3 class system, because these classes are generated dynamically and there's no strict definition. So here's the example. We have a function called myFunction. It resides in the package myPackage. It's going to give a warning indicating that the arguments provided don't match, and I'm going to ignore one of them. So the line might look something like this. If my argument is going to be ignored, throw a warning. So package warning, and then argument Y is going to be ignored. And the type is ignored argument. So when package warning is called, it would raise errors with all of these classes. My package, my function, warning ignored argument. Oh, and as a side note, that's an index concatenate operator. You're welcome. I'll talk more about that in a minute. So we have very specific class system that says this is exactly the type of error from the function, from the package that it was called, to the very, very general and say this is a condition. This is a warning. So if you have something that catches all warnings, such as suppress warnings call, it will be caught by an error. A warning raised by this will be caught by that because it's the proper class. But you can also use the things like in the middle, where my package warning, I want to catch all warnings coming from this package and do something with them. So it's like, I know that there's going to be a warning here. It just always throws it. It's pointless. ignore that warning. If it was classed properly, I could just say throw all of these warnings of this type out. So, such as throw all my could not converge errors out because I'm running 1,000 simulations and 20 of them are not going to converge because of randomness and stuff. So, catching and suppressing. So, if you raise it, if you're throwing errors, warnings, messages, you need to catch those and deal with them somehow. That's an integral part of the try-catch system. This works with the test that framework already. If you don't know test that, and when you develop a package, you will use test that. It's fantastic. And you can just say, hey, this code, I expect an error, and this is the class that I expect that error to be. It's already there, just isn't used very often because because it's difficult to class your errors before you throw them. So if this says, I expect my function to give a warning, that's how I would test that, yes, it does that warning. Don't have to modify test that at all or anything. So package condition also provides enhanced suppress warnings and suppress messages. So you can run code and suppress all the messages that match a regular expression pattern, such as the convergence errors or the bad argument errors. If it has a pattern that you can identify, say, suppress all of those, pass everything else through. And you of course can do it by class if the errors or if the warnings and messages are appropriately classed. So, as a bonus from package condition, you get the infix operators to help make warning messages. So the double arrow is a concatenate with a space. A triple arrow is concatenate without spaces. And the %/% is concatenation with a new line. That was really hard to get R to like, but it's there now. I got it. Comma list, I think I've seen other versions of this, but you throw it a list of things and it will create a properly English formatted, so like A and B or A, B, and C, and you can there's a couple different options with it, and a not in, just because there really needs to be a not in operator that is just there, because how many times do you have to do not in? Yes, it's annoying. So, next, Parse Tools. So, I am going a little bit out of order, and there's a reason for this. Because they build on each other. So, Parse Tools uses package condition and stuff. Parse data. A lot of people are not going to be getting into parse data unless you're dealing with things like linter. So you're worrying about how your code is, if it conforms to standards, if it does those kind of things. So bear with me for a minute. This is also for YouTube and to have a record of what I've done, so that people, when people ask, hey, what have you done? I can point them to this and say, hey, go check out my presentation. So you take code, source code, and that goes into a parse tree, where it's a network of all the different tokens and how they relate to each other. And from that parse tree, so from that parsed expression, you can get parse data that has where was this token. Is it a token? Is it or an expression node, which is, I'm going to join these things in a couple different ways. And basically it all goes down to the leaves, which are, is this a operator, like a plus or a minus? Is this a symbol, like variable x would be a symbol, or it can be a string, string literal. So when you put quotation marks around something or a single quotation mark around something, that's a string literal in the code. Important for what I'm doing is the comments that says, this is a comment, and then this will categorize those comments and say, this is a documentation comment. These are, so there's documentation comments. I've seen comments used for other things like plumber. I've seen comments that have directives in there. There are tag comments that I'll show you a little bit later that do some useful stuff. And then there's just plain old normal regular comments that just there, and you can have commented code and stuff like that. So Parse Tools provides the functionality for identifying elements when you're going through the parse tree to identify what relates to what. What, and particularly, where does this comment relate to? What does it belong to? Which function does it belong to? Does it belong to something else? And then you can navigate those nodes and say, okay, what's the next node? What is a child of this? So the expression and everything that goes into it. So when you've got a function, you've got an arguments, you've got a body, and all of that belongs to it. And you could say, just grab the body of the function, and then it says everything that's in the body of the function. This may be boring, it may not be glamorous, but this is the backbone for a lot of functionality that comes in to other things, into documentation, into TestsExtra, into those things that provide some very useful functionality. Speaking of TestsExtra, that's our next package. And this definitely builds on Parse Tools. And this provides what I think are some missing functionality in testing. So things like all inherit. I've got a list of objects. Do they all inherit? Are they all of the same class? This is important for documentation, because if I have a list of documentation objects, I want to make sure that everything in it is documentation. The same thing with R, and they work a little bit differently. One works by is, and one works by inherits, and those function differently in R. Sometimes one will give a positive where the other one won't. Differences in the class system, S3 versus S4, and how the classes are registered. So also I want to say, is something exactly. I want to make sure that this is a function documentation object, not a method documentation object, which inherits from function documentation. So a method object is a function, a method documentation is a function documentation, but I want to make sure that's not that. So it's not inherited. It is exactly that. Also, checking for strings, checking that something's a non-empty string, something that's an optional, so it has to be non-empty or it has to be missing. And then validity, just for adding, I expect this object to be valid. Just a way to add quick and easy tests in test that framework. Those are all nice, but where TestsExtra really shines is embedded testing. So we have our oxygen, or Roxygen, that lets us put our documentation in our code. TestsExtra lets you put your tests in your code. So here's an example. I've got a function, simple function, hello world, hello. And then I've got a block after that and says, okay, this is a testing block. If I source that file, that block's not going to be run because it's missing a parentheses. Ignore that. There should be another parentheses after the false, but you can tell I didn't use R Markdown for this. I'm sorry. I've wanted the fancy transitions. So this tag says, this is a block of testing code. What's it testing? Whatever I just did. If I just defined a function, I'm testing that function. If I just defined a class, I'm testing that class. If I just defined a S4 method, I'm testing that S4 method. You can also add information in there to say, okay, I am testing this specific case. I'm testing the edge cases. I'm testing the errors and the warnings and the conditions that are coming out. So some of the code has lots of testing, and so you group it down into smaller parts. And this generates those test files that are used in test that in the package building system. Eventually, I'd like to see something like this where it doesn't necessarily have to be translated into another file and it can test those directly, but that's down the road. So basically what this does is it takes that, extracts that block of code, you run extract tests, and it creates this in a file in my tests/test that directory, and I get context. This is the tests that are extracted from my hello world.r, and then it just basically copies it over. But it adds some extra stuff like the line directive. So when a test fails, it will tell you exactly where that fails. And the line directive says it will show you in the original file, not the test file. Very helpful. Okay. Let's talk about the experimentals. And I'm not going to talk a lot about these because, well, they're experimental. So the extended reference, or extended ref, is extended reference classes. Now, I am aware there are several class systems for R. There's reference classes. There's S3, there's S4, there's reference classes, there's R6. There's they're not proxy, prototype classes. There's a the ggplot class system. It has its own class system for those. They all serve a different function. It was decided in the R documentation task force that we wanted to use the built-in class systems. We wanted to use the built-in systems, the S3, the S4, and the reference classes. I ran into a couple problems and said, okay, I need support for things like static variables so that I can create a catalog of all the documentation objects. So if a documentation object is created, it stores it in the catalog. That is not supported anywhere in R as far as I am aware. So extended ref actually builds that into the reference class system, and it supports private variables, it supports private methods, it supports static variables, static methods, and importantly, the extended ref is reference classes. So every object that is a extended reference class is also a reference class object, and that was kind of important for what I'm doing, for what I was doing in the documentation package. Post logic. This is the most experimental one that I've done. It's a very small package, and all it does is provide postfix and infix logical operators. And sometimes they work, and sometimes they don't. But it comes in useful if you're doing something like debugging or something and say, okay, throw a message unless this condition is satisfied, or do this if, an early kick out if. I saw this in Ruby as a language. I'm like, man, there are times that is really, really useful. And so I implemented it, and there is no time where you can't get away with a regular if statement, but sometimes it's convenient to write it this way. I don't know if any of my packages currently use it, but it was kind of a toy that I tossed out there. So yes, as again, very experimental. Okay. RD format. The RD is to the language RD as HTML tools is to HTML. Who has played with Shiny objects or with Shiny pages? A lot of people in here have. Anybody use directly HTML tools to create HTML web pages and stuff? Okay. HTML tools is behind a lot of that Shiny stuff. So that's the underpinnings of several of these things where it says, if you're going to create a web page, it's got to create a HTML tag. It's got to create a head tag, a body tag, and all of these things. And HTML underpins all of that. RD does the exact same thing for RD. You create a alias, name, title, description, details, all of those things, and then you can nest them into a format. You can see why this would be important if we're trying to write out our RD formatted documentation. We gotta convert it into RD format. Somehow, that's what it does. Importantly, it extends the toRD function. This is actually a base R function in the tools package, but it only works for 1 or 2 classes naturally. And so this extends it to a full S4 generic. You can pass anything into it, and it will say, okay. So you can just say, I've got a documentation object. Make that RD format and print it out. So the toRD it underpins all of that. I don't want to go into details of RD. That would just be really boring. I don't think anybody is interested in that. If you want to, go look at the help files. So we've got all these packages. We're bringing them all together into documentation. Documentation is I want to say a massive project. There are S4 classes defined for lots of stuff: arguments, argument lists, default values, keywords, namespace entries, so all your imports, exports, import patterns, those kind of things. Different types of formatted text that can be embedded in documentation and converted between formats. Documentation for functions, of course, that's what we're documenting most of the time. Documenting objects for documenting data, examples, usage syntax. I could go on. And then it defines the functions for reading in formats and converting them into the natural R objects. So we're working on reading in RD, not quite there yet. In fact, converting from R Oxygen works really well because they did most of the work for me. And I just have to say, okay, you're giving me back a list, and it already includes what the tag was and stuff, so it makes it very easy to convert directly from R Oxygen. I don't have to do a lot of parsing on my own, except for in a few cases. So it also includes examples, includes support for embedded examples. Like I said, the tests. Now your examples through using documentation, your examples won't have to be embedded in a comment or an R Oxygen comment. You can just put if false hash at example, and it's an example for that function, and it will be picked up. So you can more easily check syntax and those kind of problems with it. RStudio does a really good job of that already, but this takes it a little bit step beyond what RStudio does. So, where are things now? Current work is focused on documentation objects that are shared across multiple functions and multiple objects. So you'll find a lot of documentation files where the class documentation file documents all of the methods, kind of thing. That would be considered a shared documentation object. The idea is that in R, you can pull up an object and say, I want the documentation for this thing. and it will go out, look to the catalog or whatever. It's all masked to the user. It just says, where's the documentation for it? Does documentation exist? And then pull it back. When there's documentation objects that are shared across things, or a documentation object that is a composite of things, so like a class documentation that would be a composite of class, the fields of that class, and the methods of that class, that all naturally fit in a single documentation object or in a single documentation page, or they may not. So all of those kind of shared documentation and composite documentation things are where things are working now. All the basic classes are there, I think. But that's what we're working on. That's what I am working on now. And also extending support for different formats like writing to RD, reading from RD, writing objects directly to HTML, so kind of things. Those are all things that I am still working on. If anyone is interested in helping me, please contact me. I've got lots of little tasks of stuff that just take time but are fairly straightforward. That's a programming principle that I'm trying to follow, is that functions do one thing and they do it very well, and they do it. They're just straightforward, very readable code, all that stuff. So, thank you. Do we have questions from the room?
So all these projects are under the RDoc task force? Is that
Yes.
what I should do?
Yeah, so go check our GitHub. All the packages are there in their current state. Not all of these are released to CRAN. Parse Tools is, TestsExtra is, Package Condition is, and RD is. Oh, PostLogic is as well. I don't believe I've released the extended ref and the documentation package itself. While it's not on CRAN, because they're still missing functionality. I'm going to try and get a kind of a beta preview kind of thing out as soon as I get a few more things in there to where it's an actual usable working system. It's not quite there yet. I want to get more of reading in files from RD locked down, and then I can say, yeah, that's where we can really push it out. And so I am probably going to be, this was an R Consortium task force, an R Consortium project, an R Consortium Working Group. The funding has been expired for a while. I'm still working on this here and there. I am probably going to put in another application to say, well, I underestimated how much work there would be. Of course I did. So please give me more money. But that's where things stand at the moment. For most users, it won't impact a lot of what they do. It could impact if you are writing functions. You should be able to put all your code in there and then just wrap it in a tag that says self-document this or document that this is a documented function, not a normal function, and it will say generate the documentation with it, so that without necessarily being embedded in a package. So if you have, like here at the university, we have scripts, not necessarily packages, but scripts that do things like create a table 1 in specific circumstances. It would be really nice to have documentation that if you pass that on to someone, they can pull it up and say, oh, that's what I'm doing wrong. I'm putting this where I should be putting that, kind of thing. Having that documentation carry along independent of the package system could be really useful in a lot of corporate scenarios. Not only mention that, I think that places like RStudio would really benefit from that. Just having if you define a function and you define the documentation, RStudio can pull that in as soon as it's ready and start giving you the auto-completion kind of stuff and says, this is what that argument is, which is what you get for regular packages. But if you define your own function that you use all the time, but you haven't put it in a package, well, you should put it in a package, but I know that people aren't going to do that. So things like RStudio can start doing that kind of stuff. So I think it would be really beneficial for them. That's where I am going with this.
I have a question about TestsExtra. So as you have used it, what have been, like in real life, like what have been the benefits you've seen to having tests along with functions versus having them in separate files?
Oh my gosh, I would never go back to having tests in separate files. Never. That is the way I program. So I write a function, and then I just scroll down and say, okay, here's the tests that I need to do, and I can look back and forth and say, okay, what do I need to test about this? Have I tested all of the arguments? Have I tested all of the edge cases? Have I tested all of the stuff? And it just says the proximity of having tests to the code. It's the same thing as the proximity of having documentation to the code. If you change the code, do the tests. If you add functionality, add the tests. It's so easy to forget when it's not in the code with it, and it really takes it from okay, I'm programming versus okay, I'm testing as two mindsets, and puts them together as this is programming. You write code, you test code. You write code, you test code.
Like you document,
Yeah, you write code, you document it, and you test it. And one of the places that I hope that documentation goes in the future, I know that R is not a typed. It's a weakly typed. If it's even typed at all, it's definitely not strongly typed like C++, where you say this has to be an int to go in there, and if it's not an int, I don't know what to do. Or you can pass in anything. But there are a lot of cases where a parameter needs to be something like a data frame or a single integer. Assert that has created all of that to make it very easy to. There's a step that we can take beyond that says, if this is documented as it's a single integer, you could put it in as a one-line code, check arguments, and it will say, okay, is this argument documented? Yes, it needs to be a data frame with so many columns. Okay, is it a data frame? Oh, it's not a data frame. Kick it out. Kick out an invalid argument error, so that testing is interdependent with documentation, which is interdependent with the code. So you can add which is one of those location-dependent things. You can say, so when you write a function and it has arguments, and you say, comment this argument. This should be a character, or it should be a character with one element. That's part of documentation, is knowing what should go in there, but it's also it also can be used for testing. That's what I'm talking about with that interdependent system, where everything talks to each other and says, I can infer things that I don't necessarily need to be repeated. That's where I'm going with it. So I would never go back. To answer your question, I would never go back to testing in separate files.
I have one more question personally. Do you have concerns about the fact that this path has led you to like another object system?
Yes.
Okay.
That's why it's experimental.
Okay.
Because I readily acknowledge that I could do things in different ways, and I could use like R6.
Yeah.
I think R6.
That's what I was thinking about.
R6 is a fantastic system. It still doesn't have everything I need, but it's a good system. It's essentially typed environments, which is kind of what reference classes are.
Yeah.
Reference classes have the support and the blessing of the R Consortium and the R Core.
Okay.
So there is a affinity to try and keep within that system.
Yeah, okay.
The thing that I really needed, and I said, this is doable, is, and it's really not a major tweak to the reference classes. It's just is that static.
Okay.
Is that static support, and that's where I really haven't seen it supported other places.
Yeah.
But it would be really useful if you came in and if you could say, every time I create an object, make a counter. Every time, or
Yeah.
log it into a catalog. That comes in really helpful with documentation.
Yeah, I can see that.
That's why I went down that path, and so no, I am not convinced that that's the right path. I do, however, do things such as functions that define classes that define other classes. There's kind of that classception, inception kind of thing.
Delightful.
Yeah, so there's some of that goes on.
Nice.
Yeah.
Does anybody else have a question for Andrew? Awesome. Well, let's thank you, Andrew. That was really great and interesting.
Thank you.
And